So now we're going to start taking the limit of a sequence. So basically, we're going to ask ourselves now, what happens to the terms of a sequence as n approaches infinity? If the limit of a sub n as n approaches infinity exists, then the sequence converges. And if the limit of a sub n as n approaches infinity does not exist, then the sequence diverges. So let's do some examples of this. So determine whether the sequence converges or diverges. If it converges, find the limit. So we have this sequence here, and we want to figure out if it converges or diverges. So I'm going to take the limit of this sequence as n approaches infinity and see what happens. So does anyone know how we're going to do this limit? What I'm going to do is I'm going to divide by the term that's dominating, basically. So 5 to the power of n, that's the most powerful term in this fraction. So I'm going to divide by that. This 3 is a constant, so nothing's going to happen to that. But now I'm going to divide the numerator and denominator of this fraction by 5 to the power of n. So we have 2 to the power of n divided by 5 to the power of n divided by 1 over 5 to the power of n plus, and then 5 to the power of n divided by 5 to the power of n, that's just 1. And notice how 2 to the power of n divided by 5 to the power of n, I can make the whole thing to the power of n, like this. So when it's in this form, can you guys see what's going to happen as n approaches infinity? Does that help, or do you need more hints?
Well, for starters, the 1 over 5 to the n in the denominator is going to go to 0.
Okay, good. So 1 is staying the same as n approaches infinity. This 5 to the n as n approaches infinity is going to grow very quickly. It's exponential growth. So when the denominator gets very, very big, this is going to go down to 0. What about 2 over 5 to the power of n? What's going to happen to that as n approaches infinity?
Does it make it just like smaller?
Good. Think about what happens when n is 1, when n is 2, n is 3. When n is 1, you have 2 over 5. When n is 2, you have 2 over 5 times 2 over 5. And when n is 3, you have 3 2 over 5s. And when n is 5, you have 5 2 over 5. So if you keep multiplying by 2 over 5, since 2 over 5 is between 0 and 1, the number is going to decrease. So it's exponential decay. So this is going to go down to 0. Again, because the stuff inside the parentheses is between 0 and 1. So
3.
yeah, so this is basically 0 over 0 plus 1, which is 0. So you just have the limit as n approaches infinity of 3, so that's just 3. So does the sequence converge or diverge? So remember, if the limit exists, the sequence converges. So the limit does exist, it's 3.
3 exists, I agree.
Yes, you get a finite number. So therefore, these 3 dots mean therefore, a sub n converges to 3. So as n approaches infinity, basically the terms of the sequence are a bunch of numbers that are very close to 3. Okay, part B. This time we don't have the explicit formula of this sequence. I just wrote out the first couple terms of the sequence. So 1, 0, -1, 0, and then it cycles through again. 1, 0, -1, 0, and so on. Do you think this sequence converges or diverges? Does it look like as n approaches infinity, it's going to approach a certain value?
No.
Exactly, it's not. It looks like it just kind of cycling through 1, 0, -1, 0. So we can figure out the explicit formula for this sequence, right? Where have we seen 1, 0, -1, 0 before? Does that remind you of a certain function in algebra or pre-calc?
It reminds me of like a sine or a cosine.
Exactly. So these are unit circle numbers, right? Basically the values of sine at every 90 degrees. So like right here at 90 degrees, sine is 1. At 180 degrees, sine is 0. At 270 degrees, sine is -1. And at 360 degrees, sine is 0. So it's just cycling through that every 90 degrees. So 90 degrees in radians is pi over 2. So this is sine of pi over 2 times n. And this is if you start the index at 1. So
Some conventions disagree on whether 0 is included in the set n, but that's a different discussion.
yeah, but in the first page, I'm saying n is the whole numbers except 0. So basically, if we take the limit of a sub n as n approaches infinity, we're taking the limit of sine of pi n over 2. And that's just going to oscillate between -1 and 1. So that means this limit does not exist. So the terms are going to oscillate back and forth forever between 1, 0, -1 forever. It's never going to settle down into a single specific value. So that means that a sub n diverges. Last page. So an alternating sequence is another special kind of sequence. So it's kind of in the word. It's a sequence whose terms alternate between positive and negative values. We saw that in the first example, right? 1, -1/2, 1/3, -1/4. So it's switching between positive and negative values for every single term. So here are some examples of the form an alternating sequence can take. So there's usually this -1 to the n minus 1 times a positive sequence. Or it can be -1 to the power of n plus 1, or it can just flat out be -1 to the power of n. But this -1 to the power of n looking thing is what's going to make the sign flip every term. And again, there's this other sequence that's always positive that's being multiplied. So there's something called the absolute value theorem. This theorem says that if you take the limit of the absolute value of a sequence as n approaches infinity, and that's 0, then that means the limit of a sub n without the absolute value is also 0. So this is true for every single sequence. You can prove this very quickly. Let's say a sub n is a random sequence. Some terms are positive, some terms are negative, but we know that if I make every single term positive, I can say a sub n is less than or equal to the absolute value of a sub n, right? If I make every single term positive, then a sub n is going to be less than or equal to that. And you can do the same thing where every single term is negative, like this. So if we know that this is 0 as n approaches infinity, that means the limit of negative absolute value of a sub n is also going to be 0.
Theorem.
Yeah, so by the squeeze theorem, we know the limit of a sub n as n approaches infinity is going to be 0.
I thought that would ever be useful for anything.
Yep, that's
Arguably, it still isn't. When would you ever bother proving this?
squeeze theorem always pops up. So again, this works for all sequences. It can be a sequence with all positive terms, all negative terms. It can be some positive, some negative. But this note is only for alternating sequences, and it can be for sequences that are strictly alternating, like one term's positive, the next term's negative, the next term's positive, the next term's negative, like strictly alternating between positive and negative. Or it can be a sequence that maybe initially it's not alternating, but eventually it becomes alternating. So either way, if the limit of the absolute value of a sub n as n approaches infinity is not 0, then the limit of a sub n as n approaches infinity does not exist. So we're going to see some examples of that in a second, and you'll see how that's going to be used. So same as the last example, determine whether the sequence converges or diverges. If it converges, find the limit. So we have this interesting sequence here, and I want to figure out if it converges or diverges. So what do I need to do?
You want to use that theorem that has the absolute value in it, and then you're going to take a limit of that, and we will see what comes out of it.
Yes. So we're going to take the limit of the absolute value of this as n approaches infinity. It's good to take the absolute value of this thing because what's going to happen when I take the absolute value of a sub n?
Well, the alternating part ceases to matter.
Yeah, this part basically disappears because that's the part that's making the signs alternate between positive and negative or negative and positive. So we end up just taking the limit of this basically. Let me ask the audience now. Do you guys know how you take the limit of this as n approaches infinity?
Forgot the exact name of it, but something to do with like
looking at what's the highest power.
Okay, good. Yeah, the term with the largest degree, with the largest exponent is going to be dominating, basically. So what I'm going to do is I'm going to divide the numerator and denominator by n squared. So
Also, you wrote down +1 in the denominator. I mean, you wrote down -1, but it's +1, except it doesn't matter.
Yeah. Okay, good catch. Thank you.
It's crazy.
So I'm going to divide the numerator and denominator by the most powerful term, which is n squared. So I'm going to get 8 plus n over n squared, that's 1 over n, minus 5 over n squared, divided by, the n squared here is going to cancel, so you just get 5 minus 2n over n squared is just 2 over n, so we're going to subtract that. And we have plus 1 over n squared. So as n approaches infinity, these denominators are going to get very big, and all these fractions are going to drop down to 0, basically. So you're just left with 8 over 5. So that's what the limit is. The fast way of doing it is you can just look at this function and notice that they both have an n squared, and you can just divide the leading coefficients and just say 8 over 5. We found the limits of the absolute value of a sub n as n approaches infinity, and we got 8 over 5.
What was the question asking?
So the question's asking, does the sequence converge or diverge? So what does this mean when the limit of the absolute value is 8 over 5? And this is an eventually alternating sequence. What's happening is, as n approaches infinity, if you look at the graph, the terms of the sequence are oscillating between 8 over 5 and negative 8 over 5 as n approaches infinity. We just took the absolute value and we just got 8 over 5. But without the absolute value, it's really bouncing between 8 over 5 and negative 8 over 5. So that means, based on this little note here, that the limit of a sub n without the absolute value does not exist, because the limit of the absolute value of a sub n as n approaches infinity is not 0.
Oh, that's the first time I've seen the intuition for why that's true.
Okay, good. Yeah, so since this limit does not equal 0, therefore a sub n diverges. Again, it's bouncing between 8 over 5 and negative 8 over 5 as n approaches infinity. So it's not approaching a single value. Any questions on this problem? Ready for part B?
I'm so excited.
Last problem of today, and then I'll set you guys free. We have another sequence that's alternating or eventually alternating. So I'm going to take the limit of the absolute value of this sequence as n approaches infinity. So again, this negative 1 to the power of n goes away, and you really are taking the limit of this right here. Can anyone tell me what you do to find this limit as n approaches infinity? Any suggestion is great. Let's look at what happens when n approaches infinity. So natural log of n, what happens to natural log of n as n approaches infinity? The graph looks like this, right?
It approaches infinity.
So this keeps increasing. It doesn't cap off. So as n approaches infinity, natural log of n is going to go to infinity. And n cubed, that's also going to go to infinity. So we have this infinity over infinity situation. So does anyone remember what we do when you have a limit that results in this indeterminate form of infinity over infinity?
There's a rule which has a very French name.
Oh, L'Hopital.
Good. Yes. We're going to use L'Hopital's rule right now.
The hospital's rule.
El Hospital.
So I can take the derivative of the numerator and denominator with respect to n, and the limit stays the same. So derivative of natural log of n plus natural log of 2 divided by the derivative of n cubed minus 4. So this is just applying L'Hopital's rule. So we can take the derivative term by term. So what's the derivative of the natural log of n with respect to n?
Yeah, 1 over n.
Yeah, 1 over n. What's the derivative of the natural log of 2?
0.
Okay, very good. because natural log of 2 is a constant, so the derivative is 0. It's not 1/2. Okay, so that's it for the numerator. You just have 1 over n. What about the derivative of the denominator? What's the derivative of n cubed minus 4?
3n squared.
Good, yeah, because this minus 4, the derivative is 0. So we have 1 over n divided by 3n squared. So this 1 over n, the n can go in the denominator, and you get 1 over 3n cubed. And what's the limit of 1 over 3n cubed as n approaches infinity?
0.
0, exactly, because the denominator gets very big, and the numerator is just 1 the whole time. So you could have just known it's 0 from the start, because cubic functions grow faster than logarithmic functions. And you could have just said, oh, it's going to go to 0 because the denominator grows much faster than the numerator. But this is how you'd show it. So what does this mean? Does a sub n converge or diverge if the limit of the absolute value as n approaches infinity is 0? If the limit of the absolute value of a sub n as n approaches infinity equals 0, then that means the limit without the absolute value is also 0. And if the limit exists, then it converges. So it does exist, it's 0 for the absolute value and without the absolute value. So therefore, a sub n converges to 0. So do you guys understand how to treat alternating sequences? It's a good idea to take the absolute value. And if you get 0, it converges. And if you get something different from 0, then it's going to oscillate between the positive and negative version of that number, and it's going to diverge. So that is all I have for today. So if you found this video helpful, make sure to like the video and subscribe. You can leave any questions you have down in the comments below, and I'll see you guys in the next video.
Bye.